So just to review some of these symbols, remember the one that looks like an E is an element of. The one that looks like a sideways U with a line under it is subset. And then you have the U, which is union, and the upside down U, which is intersection. And so those are kind of the symbols that we've gone over. So we have seen an element of, this one made me do it with a line under it. So that is element. That's element of a set. This is going to be your subset. You have union, which means put them together. And you have intersection, which means tell me where they intersect or what they have in common. So those are the set symbols that we used. And you'll see those again in geometry as well. So we also have empty set. All right. So the first few have a T or an F. That means true or false, right? You just have to circle which one it is. The first question, what is it asking? 3 is what? What is that symbol? Element. That means an element is one of the pieces inside of a set. So 3, is that an element of A? True or false? That is true. What about 2? 7 is an element of B. That is false. What about 3? B is a subset of C. True. And what about 4? The empty set is an element of C. Those of you that said false, you're correct. The reason is element can only be used for elements. But this symbol we said was empty set. So when you're comparing a set to a set, you're going to use the subset symbol. The subset symbol, right? And so if it had said the empty set is a subset of C, that would have been a true statement. But element, the subset, the empty set has no elements, right? But it is still a set, okay? And so when you're comparing sets to sets, you want to use your subset notation. The next question is not a true or false. It's telling me to list the set of numbers. And so what does that symbol mean? We are looking for where they cross over. So you go through the elements and you say 1 is also in C and it is in A. That's going to be it. 3, well, that's in both of them. 5, well, that's in both of them. 7 and 9. That happens to be all of them. It may not always be all of them, but you want to make sure you list the ones that fall into both of these. If it had said union, you would have listed all the numbers that are in them together, but you don't repeat anything if they're in both, okay? Make sure you use your set brackets. Those little squiggly brackets tell me that you're talking about a set. So make sure you use those as well. We start with natural. That's our counting numbers, 1, 2, 3. We get to whole. Whole includes all my natural, but also the number 0. So you'll see they put 0 in here. Integers, that introduces negatives. All right, so it's your whole numbers and their opposites. Rational numbers introduce fractions and decimals, as long as the decimal stops or repeats. All right, if it stops, it terminates, or repeats, then it is a rational number. If you have a decimal that keeps going without repeating, it is an irrational number. The most common ones that you will see are the square roots that do not have a perfect root. And then, of course, this little guy. The reason we know that these are not rational is because this has no pattern and it does not repeat. This has a pattern, but it's not a repeating number because I'm not going to continue on with 3. I'm actually going to have 2, 2, 2, 2. And even though you see a pattern there, it's not a repeating number. All right, so there is a difference between seeing a pattern and actually having a number repeat. Now you can have multiple numbers repeat, just like this guy down here, but you will see that line above it, 153, 153. Or if you see 153, 153, 153, then you can assume that's repeating numbers as well. But the other ones are not repeating and they do not stop. All right? So your instructions say name the set or sets. That means I want all of the sets, not just the smallest one. So find the smallest one and then list the ones out from there. So if I look at the number 0, what's the smallest set that fits into? Whole numbers. And so my whole numbers is my first set of numbers. But then I need to list all of the other ones that it's a part of. So it is a part of whole, but then it's also a part of integer. It's also a part of rational. And all of these are real. All of these are real. If you do not want to do your symbols, you may write out the word, but make sure you write out the correct word. All right? So most of the symbols go along. Natural is in, whole, real. Those kind of go along. Irrational. But the weird ones are rational is Q and integer is Z. All right? So those are the weird ones, but everything else goes with the number with what you would think for the set. All right, what about 7? Does square root of 93 have a perfect root? No, it does not. So what's the smallest set this fits into? Irrational, and they are all real. So that is an element of those. You don't have to put your element symbol, but... All right, 11. What's the smallest one it fits into? Natural. So this is going to be all but irrational. So natural, whole, integer, rational, and real. All right. What about 19 over 6? It is rational, which means it's also real. So it's rational and real. Now, if it had been 18 over 6, what would I have said? What if I had said 18 over 6? Yeah, natural, because 18 over 6 is 3. So you may want to make sure that you can't simplify it before you decide, because you are talking about in its simplest form, what is the smallest one it can fit into. When you are adding, these are adding rules. If you are adding two numbers with the same sign, you just add and keep their sign. If you are adding two numbers with different signs, you're just going to subtract and keep the sign of the larger absolute value. All right, so whichever number is bigger in an absolute value sense, then you keep that sign. So some of you may want to change your subtraction to addition. Here's the thing. Your first number, you always keep it. So like on number 10, don't change -6. He's your first number. Always keep your first number. The only ones that you may want to change are your subtractions. So after your first number, you look for a subtraction sign. So here, keep this guy, but I have a subtraction. We can change our subtractions to addition, but then I have to flip the sign of the next one. So I'm going to keep the first guy. I'm going to change that to addition, and I'm going to change the next one. So adding the opposite. If I change my subtractions, I am changing them to adding the opposite, which means I never change my adding ones. After the -8 that I just changed, I have another subtraction. So I can also change that to adding the opposite as well. All right, now that it's all addition, you can actually add in any order you want to because it's all addition. So some of you may want to put the 6 and the 3 together because those are both negative. Or you may just want to go straight across, right? It depends on how you feel you add the best. But once you change it to all addition, you can do it in any order you want to. So I'm going to show you a couple ways that you could do this. You could just go straight across. I have a -6 plus 8. Those are different signs. What do I do with those? Go ahead. Wait.
So it would be 2.
So it would be 2. I'm going to subtract 8 minus 6 and keep the sign of that. And then I have a plus -3. And so I'm going to do the same thing here. Subtract. 3 minus 2 is just 1. But now which one was bigger, my positive or my negative? my negative. So my answer here is -1, okay? Yeah. So you could do it where you group them if they're all addition. Or you may just go straight across and your brain does the subtraction fine. All right, so I did add some fractions and decimals on here because that tends to be where we dislike our addition and subtraction. I will say I personally change mine to improper fractions because borrowing with fractions tends to be harder than just adding our numerators. So if I were to change this to an improper fractions, 4 times 4 is 16. 16 plus 1 is 17. That's -17/4. Improper fraction, 2 times 1 is 2, plus 1 is 3. So that's going to be 3/2. And I need a common denominator. Between 4 and 2, what's my least common multiple, my common denominator? It's going to be just 4, right? So I can multiply top and bottom by 2 here. All right. So I have -17/4 plus 6/4. Same sign or different signs? The same sign. Remember, when you're adding fractions, your denominator does not change once you have found the common denominator. So I just have to worry about the -17 and the 6. They're different signs. Subtract. What is 17 minus 6? It's 11, and it's negative because the 17 was negative. Correct. The question here is, if I were to change this to adding the opposite, is it just the 2 or the whole thing? Technically, it's the whole thing, but you only have to worry about your numerators. So it's not negative over negative, it's just one of them are negative. And so it's probably easier at this point to write it like this. -9/7, that means the same thing, plus -2/3. Just leave your negatives with your numerator, and that may be easier. So your denominator can just be the positive piece, and the numerator can be your negative, because just one of them is negative. But it technically means the whole fraction is, because you have one negative and one positive, which means you have a negative, right? So we do need a common denominator here. And yes, I would change this to adding the opposite like we just did. What's my common denominator between 7 and 3? 1. So in this case, all I have to do is multiply. And by the way, if you're bad at common denominators, you can always multiply your denominators, but you may get a larger number that you have to reduce at the end. And that's fine. But if you struggle with common denominators, multiplying them will always give you a common denominator, even if it's not the lowest one. In this case, it is the lowest one. So I need to multiply this one by 3, and I need to multiply this one by 7. So I get what here? -27/21 plus -14/21. Remember, once I have my common denominator, that is my denominator. I'm adding the same signs, so I'm just going to add them. 27 plus 14 is 41. They were both negatives, so my answer is going to stay negative. This one, how I would do it. So I'm going to see that this is adding the opposite. So I now have a 6.4 and a -7.2. Different signs, okay? Right? So I'm going to subtract these. But because it's decimals in my brain, I'm just going to write it down as subtraction, right? And then I'm going to go ahead and remind myself that my answer is going to be negative because the 7.2 is bigger than the 6.4. So you're going to subtract these. Remember, for this, you line up your decimals. You have to borrow here, right? You have to drop the decimal down in your answer where it goes. 12 minus 4 is 8, so I get a 0.8. I decided right up here that my answer would be negative, so I just placed that negative on my 0.8. They have the same rules. If you have the same sign, it's going to be positive. Different signs, it's going to be negative. I also wrote, if you have an even number of negatives, it's positive. If you have an odd number of negatives, it's negative. Because you could be multiplying more than 2 numbers, right? And so if you're multiplying more than 2 numbers, you can just add up those negatives at the very beginning and say, oh, I have 5 negatives. My answer is going to be negative. It's all multiplication, right? So you can also look at just even an odd number of negatives. So like for number 14, I have a positive times a negative. What's my answer going to be? Is it going to be positive or negative here? It's going to be negative. Then I just have to worry about 7 times 2. That's 14. Right? With fractions, the positives and negatives work the same, but I do want to change it to an improper fraction always. You always want to change it because it's technically distribution when it's a mixed number, and nobody does that. So we want to do 3 times 8, which is 24, plus 5, which is 29. So I have 29 over 8, and that is negative. I am multiplying that by a negative 4 over 3. Negative times a negative. What do I know about my answer here? Positive or negative? It's going to be positive. All right, so negative times a negative. My answer is going to be positive. I could just multiply across here, but is there something I could do before that? Yeah, I can simplify before. Remember, any top to any bottom will simplify. So 4 goes into 4. 4 divided by 4 is 1. 4 also goes into 8. 8 divided by 4 is 2. And now I'm ready to just multiply across. 29 times 1 is 29. 2 times 3 is 6. I already decided that my answer would be positive, and then I'm done. So division has the same rules of positives and negatives. You could just see an integer over an integer, and that's just division. So I have 18 over 3. That just means 18 divided by 3. It's positive divided by a positive, so it's a positive, and it's going to be a 6. So don't overthink it if you see that. It is a fraction, but it just means division. And then you could have division of fractions. And so you have keep, change, flip. I think y'all have another one, stay, flip, flop or something. Is that skip, flip, flop? And so the basic for keep, change, flip or skip, flip, flop, whichever you do, is that the first number doesn't change. Okay, the first number just stays the same. So I will always leave this negative 3. However, before I do that switching around and changing that last one, I want to change that to an improper fraction. So I'm going to say leave this as a division right now and change that improper fraction. So 4 times 1 is 4, plus 3 is 7, 7/4. So that's what I'm dividing there. All right? Yes.
How do you know?
So keep, change, and then we're going to flip the next one. And because they're negative times a negative, my answer is going to be positive. I can cross cancel. What can I cross cancel here? 6 and the 4. 4 divided by 2 is 2. 6 divided by 2 is 3. I can multiply across. 11 times 3 is 33. 2 times 5 is 10. It was negative times a negative, so my answer is positive. So multiplying like bases, you just add your exponents. All right? Add your exponents. If I have a squared times a cubed, I have a to the 5th because I have a times a, that's 2 of them, a cubed, a. At the end I have 5 of them, right? So that's why when you multiply the same base, you just add the exponents. When you have a power to a power, so you have x squared and that whole thing is raised to the 3rd, then you're going to multiply those, all right? When you have more than one thing in a group and the whole group is raised, everything in the group goes to that power. That's what the next one says. If I have a negative exponent, that actually just reciprocates it. So if the negative is up top, it puts it in the bottom. If the negative's in the bottom, we put it to the top. Okay? If I'm dividing, we subtract the exponents. And something that's not listed here is anything to this power equals what? 1. Not a to the first. It literally is the number 1. Okay? So let's look at the examples that we have on our handout. All right, the first thing I like to do is kind of put together things that go together. All right? So when I have something like this first one, then I like to put my 4 and my 3 together. So I'm multiplying 4 times 3. I like to put my x's together. So that is also being multiplied by x squared and x to the 4th. And if you want to underline them or something to make sure that you've accounted for everything, you can do that too. And then that is all being multiplied by y to the negative 3. All right? So I'm multiplying 4 times 3. What is 4 times 3? 12. I have like bases that I am multiplying. What do I do with those exponents? We add them together. So I have x squared and x to the 4th. I have x to the 6th. I have a negative exponent. He's just sitting up there. Where does he need to go? On the bottom. And once you move him, the exponent is positive. Once you move it, the exponent is positive. Okay? The next one is a group taken to a power, which means everything in the group needs to be taken to the power. I'm going to say 2 to the second power. I'm going to say x to the second power, and I'm going to say y to the second power. This one's not so bad. The only thing I need to continue and simplify is that 2. 2 squared is 4. X squared, y squared. And I'm done. All right. The next one. For now, I'm going to leave the 2 and the v to the negative 4 alone, because this is a power to a power. What do I do with a power to a power? Multiply. So this is v to the 9th. I leave this alone because it doesn't have anything to combine with. These are like bases being multiplied. What do I do with those? It's technically add, but because it's adding two numbers with different signs, right? That means we're going to subtract. We have negative 4 plus 9, which gives us v to the 5th power. It is just a positive power. It stays where it is. We're done. I'm going to show you a couple ways to do this next one, okay? First of all, we always want to simplify the numerator as much as we can and then the denominator as much as we can before we do anything from top to bottom, all right? So first, I have a power to a power here. 4 times negative 3 is negative 12, and the bottom is squared. So there's a couple ways you can do this. First, if you have any negatives, you can go ahead and move them around before you do anything, right? So I have a negative I need to deal with. Where is he?
On the top.
He's in the top. So I currently have a v squared in the top, but I also need to move my v to the 12th down, right? Sorry, v squared in the bottom, right? V squared's already in the bottom. The negative on top tells me I need to move him. And Jackson, I've moved everything from the top, so what do I need to put in the top? A 1, right. So I have 1 over v squared, v to the 12th. I have two bases that are alike being multiplied down there. What do I need to do with their exponents? Add them. So I have 1 over v to the 14th, okay? There's another way you can do this, all right? I'm going to show you over here for those of you that might like this method. What does my division rule tell me to do with those numbers? Subtract. So I have v to the negative 12 minus 2. What is negative 12 minus 2? Negative 14. What does negative 14 tell me to do with that v? There we go. Reciprocate him. So either way works. If you find that those negatives are blowing on your mind here, you can move them around first before you combine anything, right? So if we have a negative in the bottom, move them to the top. If you have a negative in the top, move them to the bottom. And then you can see what you have in common to add your exponents, right? Or you can simplify and do your subtraction from top to bottom. Whichever makes more sense to you is fine, okay? Parentheses could mean that you have parentheses. It could mean a bracket. It could mean an absolute value, or it could mean you have a numerator and a denominator, okay? Exponents, of course, that's anything that has an exponent on it. Multiplication or division from left to right. That doesn't mean do all your multiplication first. It means whatever comes first. Addition and subtraction is the same way. It doesn't mean all addition first. It means whichever comes first between those two from left to right. All right? So let's look at some of these. When you see parentheses around a single number, that's probably just telling you that it's a negative. All right? That's not technically a grouping because there's nothing to group it with. But if you'll notice, I do have grouping here. This is a group and this is a group. So I need to do order of operations within that, but this is just left to right. So I have -2 plus 5, that's different signs. That's going to give me a 3. I have a +3 and a -8, different signs, subtract. That's going to give me a -5. And then I have a -5 plus 2. That's going to give me a -3. So this whole group, when I add and subtract, gives me -3. That is being divided by 3. That's all I have left to do. I get -1. So all I had was one big group and then a division. On the next one, I have exponents. The negative is inside my group before it is squared. What is that -5 squared?
-25.
+25 because the negative is inside. So I have -5 minus 1 minus a -5 plus 25. You may want to change these to adding the opposite. You definitely want to do it here, right? You can do it here. -5 plus a -1 is -6. -6 plus 5 is -1. And -1 plus 25 is 24. Or if your brain saw that -5 and +5 canceled, you could have jumped to the -1. All right. I don't have any visible groupings on the next one, but what do I have? I have a division line, so this is automatically grouped before I do that division. Within that, I have an exponent. 2 squared is 4. Then I'm going to do that addition and subtraction. I have 14 minus 2 gives me 12 on top. That's being divided by -6. +12 divided by -6 is -2. On the last one, pay attention to this guy. He is for the whole fraction, but it's easiest to apply him to this up here. So if you see a negative in front, just put it with that numerator. I have an absolute value. 4 minus 4 is 0, and the absolute value of 0 is 0. Good question. All right, so then I'm going to combine that 0 and 4. I have -8 divided by +4. That equals -2.